All right, welcome back to West Virginia, guys. Are we ready to go? Of course we are, because we cannot wait for joke of the day. So how does Moses make his tea? He brews it. Moses was a Hebrew. Okay, good stuff. All right, so now let's brew ourselves up some math by taking a look at exponents. So let's take a look first at the definition of what an exponent is. So this says this letter B is going to represent a real number. This letter N is going to represent a natural number. Now remember, your natural numbers are your counting numbers. 1, 2, 3, 4, and so on. Numbers that would occur naturally in nature. So if I have B to the n power, that's how that's worded, B to the n power, this is an exponential expression because the n is an exponent. This B right here is considered to be the base, and this n is considered to be the exponent, and the whole thing together is considered to be an exponential expression. But when you see this B to the n power, what it indicates is this base is going to be multiplied to itself that many times. So if this was, say for instance, a 4, then it would be B times B times B times B, 4 B's being multiplied together. If this exponent was an 11, then it would be B times B times B times B times B times B, 11 B's being multiplied together. So that's what your exponential expression represents. So let's take a look at some examples here. If I have 3 to the 4th power, then what that indicates is 3 times 3 times 3 times 3. 4 3's being multiplied together. Well, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So 3 to the 4th power is going to be an 81. Now, if you're like, oh, I don't know what 27 times 3 is, consider this. I could do 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. There's another way to get to it. Now, notice that this one says yes to the 4th power, but it's no longer a 3 to the 4th power. What's being taken to the 4th power? Yes, it's a negative 3. So what this one indicates, a little bit different, is a negative 3 times another negative 3 times another negative 3 times another negative 3. 4 negative 3's being multiplied together. Now, a negative 3 times a negative 3 is a positive 9. Positive 9 times negative 3 is negative 27. Negative 27 times negative 3. Well, negative times negative is positive, and 27 times 3 is 81. So I still get an 81 out of this. I need to take those equal signs out of there because I can't miraculously put an equal sign in. But that is a positive 81. Now, and also remember, we looked at our rules for multiplying sign numbers, and we said that if I have an even number of negatives being multiplied together, there's 4 negatives here, 4 is even. Even number of negatives indicates a positive result. So I could have just said 3 times 3 times 3 times 3 is 81. Even number of negatives means my answer is going to be positive. Now take a look at letter B and letter C. What's the difference between these two? Because they look an awful lot alike, but there is a subtle difference. And what is that difference? Yes, this one does not have a parentheses, but this one does. This one, the parentheses indicates take that negative 3 and raise it to the 4th power. In other words, the negative as well being raised to the 4th power. Not just the 3, but the negative as well. That's why we said negative 3 times negative 3 times negative 3 times negative 3. However, that is not what this one indicates. This one, the reason the parentheses is not there is to tell us it does not mean negative 3 times negative 3 times negative 3 times negative 3. If it meant that, there would be a parentheses around it. This one, on the other hand, what it indicates is take your 3 to the 4th, get it, and then just change the sign of whatever you got. So in other words, that 3 to the 4th, as we discovered up here, was 3 times 3 times 3 times 3, which is 81. So this is going to indicate, take that 3 times the 3 times the 3 times the 3 and get the 81. But this says now, change the sign of whatever you got off of that. So in other words, change the sign of this, giving you a negative 81. So you have to be very careful about when, excuse me. You have to be very careful about when you have a parentheses and when you don't have a parentheses. When you don't, just simply change the sign of what you got. When you do, take what's inside the parentheses, all of it including the sign, raise it to that fourth power. Multiply the whole thing including the negative by itself that many times. So let's take a look at these three. Notice again, look very similar, but there is a subtle difference, particularly between these two. Parentheses on this one, no parentheses on this one. So this one is going to indicate a negative 3 times a negative 3 times a negative 3. In other words, 3 negative 3's being multiplied together. Whoops, take that negative in there. So a negative 3 times a negative 3 is a positive 9. Positive 9 times negative 3 is a negative 27. And once again, we could have looked at it as 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. I have an odd number of negatives being multiplied together. An odd number of negatives will give me a negative as my result. But remember, the difference between this one indicates do this part and then just simply change the sign of what you got. So when I do this part, 3 times 3 times 3, I get a 27. But then I just simply change the sign of whatever I got out of that, giving me once again a negative 27. So the difference between what I see here and what I see over here, notice that when my exponent is even, because an even number of negatives will be positive, it's not going to change the result here. But here, when my exponent is odd, an odd number of negatives will definitely give me a negative, and it will not change the result here either. But in this one, I'm sorry, I was looking at the wrong one. I'm comparing these two, my apologies. Here, when my exponent is even, it changes the sign of the result. Because an even number of negatives is positive. This one said change the sign of it, guaranteeing that it's negative in the end. Difference here is an odd number of negatives is negative. And here this will guarantee a negative in the end. I will get the same result as opposed to a different result here. But notice this one. Wow, a lot happening here. In this one, what's happening is it says, let's do this part. Negative 3 to the third, meaning negative 3 times negative 3 times negative 3. Negative 3 times negative 3 times negative 3, which is a negative 27 as we saw up here. But remember, this part here says do all that, then change the sign of what you got. So I'm going to do all of this, and I'm going to get that negative 27, but I'm going to change the sign of that. And when I change the sign of that, I get a positive 27 in the end. So we have to be very careful about those exponents and about when you have a parentheses around it and when you don't have a parentheses around it. Now, let's stretch ourselves just a little bit further with this idea of our exponents. And let's take a look at the idea of simplifying those the algebraic expressions. Simplifying those algebraic expressions, remember, remove all the parentheses, combine up all those like terms. But recall that definition of like terms. They are alike because they have the same variables, but those variables are being raised to the same power. So as we look at these, trying to decide, can I combine up these like terms? Because that's what the definition said, simplify. There's no parentheses in any of these to be removed. I just combine up my like terms. Are these two the same variable and that variable raised to the same power? Both of them have x's. Both of these x's are raised to the fourth power. So yes, they are in fact the same, or they're not the same, but they are in fact like terms. This says 5 of these x to the fourth. Now those x to the fourth represent something. I'm not entirely certain what they represent, but they represent something. They actually mean 4 x's being multiplied together, and when I multiply those 4 x's together, I get some number. I'm going to take that number and multiply it by 5, but the idea is this x to the fourth represents something. Let's say it represents a green marker. I have 5 of those green markers. I'm going to put 3 more of those green markers into my pile. 5 green markers, 3 more green markers. How many green markers do I have? Well, 5 and 3 gives me 8. 8 of those green markers is what I have. So the idea here is, like we said before, when you combine up those like terms, combine the variable, or combine the coefficients, the numbers in front, combine the coefficients, keep the variables the way they are. We like that they're like variables. Don't mess that up. So retain what's making them alike. The variables is what's making them alike. Retain that. Simply combine up those coefficients. So in this one, similar idea. I've got 5 of these x to the fourths. I'm taking out 3 of them. How many of them are left? Well, when I have 5 and I take out 3, I got 2 of them. 2 of those x to the fourths that are left. Again, I'm going to work those coefficients and I'm going to retain the variables the way they are because I like that they're alike. I'm not going to mess that up. So now let's take a look at this one. 2 of these x to the thirds and 1 more of these x to the thirds. How many of those x to the thirds that I have? Well, if I have 2 of them and I throw 1 more into the pile, that gives me 3 of these x to the thirds. So once again, I'm going to work those coefficients and I'm going to keep the variables the way they are because I like that they're like terms. I'm not going to mess that up. Now finally, let's look at this one. 2 of these x to the thirds in my pile. I'm throwing an x to the fourth in the pile. Now remember, the x to the third represents something. I'm not entirely certain what it is. Let's say it represents a blue marker. I have 2 of these blue markers in my pile. The x to the fourth represented a green marker. I got 1 of those green markers in the pile. So I have 2 of the blue ones, 1 of the green ones. Can I put them together and call them blue-green markers? No, it doesn't work that way. 2 blue markers, 1 green marker. That's it. They sit beside each other in the pile. It's nice. They sit in the pile together, but I can't really put them together. So there is nothing that I can do to this to combine them up. They're not like terms, and I can only combine like terms. So this is simplified. I could write it that way. Or I could say cannot be simplified. That's another way to write it. Cannot be simplified. Or I could simply write it down as it is and just simply write it out as my 2x to the third plus my x to the fourth, indicating there is nothing I can do with it. It's done. That's the best it's going to get. But that is how you utilize the exponents in being able to simplify and combine up like terms. So hopefully this helps with the idea of exponents, remembering that in your exponential expression, this is your base, this is your exponent. The exponent tells you how many times you're going to multiply that base. Being very careful about when you have a parentheses, that indicates everything inside the parentheses get raised to that power. When there's no parentheses, you do this part and then just simply change the sign of whatever you got in the end. I hope that helps. Have a great day.